Hello, welcome to Maths with EJD. I'm taking the last video, maybe the last video on trigonometry for now, except something else comes up along the line. And it is about trigonometric equations. Trigonometric equations. Trigonometric equations are simply equations which involve the six trigonometric ratios, that is sine, cosine, tangent, and of course, these three and their reciprocals. The reciprocal of sine is cosec, right? Cosec. The reciprocal of cos is sec, and the reciprocal of tan is cotangent. So any equation, of course, what is an equation? An equation is an expression that has an equality sign. So when you say something something equals something, then that's an equation. So these are trig ratios, all right? And then you have the equality sign that makes something an equation. So any equation that involves the trig ratios is said to be a trigonometric equation. So basically what we are doing when we solve trigonometric equations is in solving trigonometric equations, right, we get the values of the angles in the four quadrants. You remember in a previous video, I talked about the four quadrants from 0 to 90. Okay, instead of just saying that by mouth, let me just write it that in solving, in solving trigonometric equations, in solving trigonometric equations, right? In solving trigonometric equations, we get we get the values, we get the values, we get the values of the angles, the values of the angles in the four quadrants, in the four quadrants, in the four quadrants from 0 degrees to 360 degrees, which satisfy the equations, which satisfy, which satisfy the equations. Satisfy the equations. That's all we are doing. Of course, in case you've forgotten the four quadrants, I won't go through everything, but I'll just remind you that we have in the four quadrant from 0 degrees to 90 degrees, all trig ratios are positive. Sine, cos, and tangent, and every other and all the reciprocals are positive. And then from 90 degrees to 180 degrees in the second quadrant, this is first quadrant, this is second quadrant. So in the second quadrant, right? Only sine is positive. So here, sine, of course, only sine is positive, and of course, cosec will be positive too, being the reciprocal of sine. But then cotangent and tangent, cosine and tangent are negative, and of course, they are reciprocals. And of course, the other thing you may want to know is, in addition to knowing that only sine is positive, you also want to know that any angle here can be expressed as 180 degrees minus theta. So whatever theta is in the first quadrant. So how do I say this? Whatever theta is here, right? If you subtract it from 180, you get the corresponding angle in the first quadrant. So let me say this, that theta in the first quadrant is equal to 180 degrees minus theta in the second quadrant. I think that's a very nice way to say that. Okay, then when we come to the third quadrant, right, only tangent is negative, is positive. So it means that in the third quadrant between 180 degrees and 270 degrees, both cosine and sine are negative, and of course they are reciprocals. So, and the expression here is this, that how do I say this? Okay, I think you should know here that the angle corresponding to whatever is in the third quadrant is the same thing as the angle in the third quadrant minus the angle in the third quadrant minus 180 degrees. You get. So it means that the angle in the third quadrant is actually 180 degrees plus the corresponding angle in the first quadrant. The reason why this is necessary is that if you have an angle in this third quadrant, so subtract 180 from it, anything you get is the angle that corresponds to it in the first quadrant, and that's very necessary. Okay. And of course, from 270 degrees to 360 degrees, being the fourth quadrant, only cosine is positive here. And of course, if cosine is positive, it means secant is also positive, and the other ones are negative. And here, The angle in the first quadrant is actually equal to 360 degrees minus whatever angle you have in the fourth quadrant. Very important. So here, of course, the angle in the first quadrant is theta 1, and then that's every theta 1 you see everywhere is all that. So, and of course, you now apply the sign, whether minus or plus. Okay, so enough said. Can we begin to take some examples? As usual, okay, here I have like 4 examples. I'm going to do 2. Okay, well, actually, I have 4 examples plus another 5 exercise, making 9 altogether. So I'm going to do, so I'll take every odd example. So I'll take 1, I'll take 3, like that. So, and then whatever is left will be practice questions. So let's go for the examples. Examples 1. Example 1, what are we required to do? Says find the angles, find the angles, find the angles less than 360 degrees, less than 360 degrees, less than 360 degrees, which satisfy, which satisfy, which satisfy 6 sine theta minus 6 sine theta equals tan theta. So we need to find all the angles less than 360 degrees which satisfy that. Okay, so let's take the solution. Of course, we have 6 sine theta equals tan theta. So how do we resolve this? So the first thing you want to do is you want to deal with this until you get the smallest possible thing to get. And of course here, this is 6 sine theta. Sine theta is small, is basic enough. Tan theta is simply sine theta all over cos theta. Okay? So if that is the case, we can multiply through, we can cross multiply. So we have 6 sine theta cos theta, and that is equal to sine theta. So the next thing we can do here is we can divide through by sine theta. So we have 6 sine theta cos theta divided by sine theta, and that is equal to sine theta all over sine theta. So then this cancels out, and we have 6 cos theta equals 1. Okay? 6 cos theta equals 1. And that means that cos theta is equal to 1 over 6. So if cos theta is 1 over 6, what is theta? Theta is actually arc cosine of 1 over 6. And if you punch your calculator for that, right, it means that theta is equal to arc cosine of, okay, sorry, 1 over 6 itself is 0.1667, right? So arc cosine of 0.1667 actually is in the first quadrant, right? That will be 80.4 degrees in the first quadrant. But we need every angle corresponding to this, every angle less than 360 degrees. So since you have got it in the first quadrant, this is more like the angle in the first quadrant. So if you quickly come back, this is 0 to 90 degrees, and sine is positive here. Oh, everything is positive there, sorry. All positive. And that is why, though we are dealing with cos, it is still positive. So theta 1, then here, only sine is positive. So since we are dealing with a positive, especially since this is positive, and we are dealing with cos, it means that it can only be positive in the, we have got theta 1, right? We can only have theta 4 again. Because it is cos and positive, we cannot have that angle in the second or third quadrant. So we only have theta 1 and theta 4. And since we have theta 1, right, theta 4 is simply going to be, of course, we already know that for fourth quadrant, for the fourth quadrant, for the fourth quadrant, for the fourth quadrant, okay, theta, we know theta 1 is equal to 360 degrees minus theta 4. So that simply means that theta 4 is equal to 360 degrees minus theta 1. And that is 360 degrees minus 80.4 degrees. So that means that theta 4 is equal to, that's theta in the fourth quadrant, is equal to 360 degrees minus 80.4, and that will be 279.6 degrees. So that we can say then, therefore, uh, therefore, the angles which satisfy the equation, the equation are 80.4 degrees and 279.6 degrees easily. Okay, so that goes. All right. So I'll take example 4 now, and then I'll write the rest out as practice questions. So you're going to have a lot of practice questions to deal with. Okay, so let's go to example 2 now. How did I write that? Was it in okay, yeah. Roman representation 2. Okay. The question is to solve 6 cos squared theta plus sine theta minus 5 equals 0. So you want to solve this for 0 degrees. For 0 degrees less than or equal to theta less than or equal to 360 degrees. So it means you are basically looking for angles in in all the 4 quadrants that satisfy this. So we go again. How do we take care of this? Of course, what we have is 6 cos squared theta plus sine theta minus 5 equals 0. And like I said already, the way to deal with this is to make sure that you reduce the equation to a level where you have just maybe sine or only sine or cos or tan, that you can now find theta on its own. So let's see how we can deal with this. All right. So this is sine theta already, and this is cos squared theta. So at least it's very good if we have them as the same. And we already know that sine squared theta plus cos squared theta is 1. So that means that 6 into cos squared theta is the same thing as 1 minus sine squared theta plus sine theta minus 5 equals 0. Okay. So that means we have 6 minus 6 sine squared theta plus sine theta minus 5 equals 0. So if we deal with this, we have minus 6 sine squared theta plus sine theta. Then 6 minus 5 is plus 1, and that is equal to 0. Okay? Then we can multiply through by minus, and then we have 6 sine squared theta 6 sine squared theta minus sine theta minus 1 equals 0. So now this looks okay. Yes. 6 sine squared theta minus sine theta minus 1 equals 0. Now this looks like a quadratic expression in terms of sine theta. So we can just make it into a proper quadratic expression by just saying let sine theta be equal to x. If sine theta is equal to x, then we can deal with it. So we have 6x squared minus x minus 1 equals 0. Okay? And if that is the case, we need two numbers. When multiplied, we get 6 times minus 1, and that is minus 6. And we need two numbers. When those two numbers, when added, will still give us minus 6. I think will give us minus 1, right? In the center, that's minus 1. So minus 6 and minus 1. So easily, I think those two numbers should be minus 3x plus 2x. Minus 3x plus 2x. Easily, I think. Minus 3x plus 2x. So in that case, now we can have 6x squared minus 3x plus 2x minus 1 equals 0, because minus 3 times 2 is minus 6 that we are looking for. Minus 3 plus 2 is minus 1. So that's what we need. Then we can factorize. So for this 2, we have 3x into 2x minus 1 plus 1, because nothing is common, so to speak, but 1 is always common. So 2x minus 1 equals 0. So we can put those together. So we have 2x minus 1 into 3x plus 1 equals 0. Okay. So in that case now, we pretty much have what we need. So we can say 2x minus 1 equals 0, or 3x plus 1 equals 0. That means 2x equals 1 or 3x equals minus 1. And that means x is equal to 1 over 2 or x is equal to minus 1 over 3. But mind you, we did not start with x. So what do? You go back to what you started with. So you recall that x is sine theta. That was the change you made initially. Don't forget. Yeah, from here, x is sine theta. Recall that. So it means that sine theta is equal to 1 over 2 or sine theta is equal to minus 1 over 3. Okay, so so here now we have theta equals arc sine of 1 over 2 or theta is arc sine of minus 1 over 3. Okay, so that means you have and easily, right? If you punch your calculator for this, right? This is more like theta equals arc sine of 0.5. So this is looking like a special angle, if you remember. So, or if you have seen the video on special angles, you'll understand this. And this is arc sine of minus 0.3333, if you like. And then that means theta is equal to arc sine of 0.5 would just be 30 degrees. And since this is sine, right? Sine will only be positive in the first and second quadrants. So it means if this is in the first quadrant, then the only other place where you are going to get an angle is second quadrant. That will simply be 180 degrees minus angle in first quadrant. That's 30 degrees. And that is equal to 150 degrees. So in the first two quadrants, you have 30 degrees and 150 degrees. So on this other hand, right, you have theta. So arc sine of minus 0.3333 obviously is going to, because this is negative, right? And we are dealing with sine. Sine is only negative in the third and fourth quadrants. So it means I only get, so this is going to give you angles in the third and fourth quadrants. And that is like, that is like 340. In the third quadrant, that's 340.5 degrees. And then in the fourth quadrant, that is, okay, or better still, third quadrant, sine is negative in both uh third and fourth quadrants. So, okay, I guess I quickly need to check what is arc sine of minus 0.333. So I'm not messing things up. So arc sine arc sine arc sine arc sine of minus 0.333 in degrees. Okay. That is like 19 point. Let me just put it at 19.5. Okay, you know what? Here we already know the answer is going to be in the third quadrant, right? So, this is going to be like minus 19.5 degrees. So, and since sine is not negative in the first quadrant, so minus 19.5 degrees simply tells you that you're going to get this angle, you're just going to have this in the fourth quadrant. So in the fourth quadrant, that is just going to be 360 degrees minus 19.5 degrees. And that is why we should have what we have. So that's like 360 minus 20 normally, right, is 340. So, but then if it's this is 19.5. This is 19.5. And that is why that is going to be what it is. Okay, this is 340.5 degrees in the fourth quadrant. And in the third quadrant, that would be like so 180. Yeah. So in the third quadrant, it's just be 180 degrees plus 19.5 degrees. So that is 199, right? 19.5. I think that should be 199.5 degrees. 199.5 degrees. To confirm that, I think, yeah, it should be 199. So to confirm that, let's see what we get. Let's check for sine 199.5, sine 199.5, sine 199.5 degrees. Yeah, correct. So that's it. So at the end of the day, we just say that we can just say therefore theta in the so we have angles in the fourth in all the four quadrants that satisfy that particular expression that satisfy 6 cos squared theta plus sine theta minus 5 equals 0. So you can just say therefore theta 1 in the first quadrant we have 30 degrees. In the second quadrant we have 150 degrees. In the third quadrant Q3 we have 199.5 degrees, and in the fourth quadrant we have 340.5 degrees, and those are the results. Okay, so on this note, let's take the practice questions, and that will be all for now. You can watch out for the fast math solutions. I'm going to solve some of these practice questions as fast maths solutions, so that you can, in case you're not able to get a hang of them, you can always follow that to see the answers. All right. So let's take the first one. The first question for the practice question would be this. Okay, we've done this. Second one, find the angles, the angles, find the angles less than 360 degrees, less than 360 degrees, which satisfy, which satisfy 3 cos squared theta plus 5 sine squared theta equals 4. Okay, that's the first. 3 cos squared theta plus 5 sine squared theta equals 4. That's one. Second one, solve 5 tan squared theta minus sec squared theta equals 11 for 0 degrees less than or equal to theta less than or equal to 360 degrees. That means still the same thing, like in all the four quadrants, all the angles that satisfy that expression. 5 tan squared theta minus x squared theta equals 11. Okay, and then we have other questions. Okay, 3 now. Solve the following. Solve the following for 0 degrees less than or equal to theta less than or equal to 360. I could as well just list all the questions out instead of doing this, but let me just do it this way. So A, you have 4 cos 2 theta minus 3 equals 0. B, you have 3 sine 2 theta equals 18. C, you have 4 cos theta equals 3 tan theta. 3 tan theta. D, 2 tan squared theta. 2 tan squared theta minus 3 tan theta plus 1 equals 0. And E, you have sine theta plus sine squared theta equals 0. Sine theta plus sine squared theta equals 0. Okay. Those are the practice questions. You want to try your hands on them to be sure you really get the gist. And of course, if you try your hands on them and you're not able to get them, watch out for check the playlist on fast math solutions. I should be dealing with some of those questions in the coming days. So like that. Thank you very much for listening all the way. If you have not subscribed, be sure to do that. And don't forget to hit the notification bell so you can get alerted each time I make a new video. And of course, You want to comment, you want to like, you want to share, so that more people can benefit from the knowledge being shared here. Thank you so much for always stopping by. See you in the next video.